Okay, so let's go back over even and odd identities. So if you remember, when we talked about this before, we had said we only had two even identities. Who remembers what those are? Remember, it's going to be cosine and its reciprocal, secant. So what that means, if you have cosine of negative x, that's going to be the exact same answer as cosine of positive x. And secant of negative x will be the same exact answer as secant of x. And remember, we compared these two to like when we looked at x squared. X squared was an even function. So when we plugged in x was a negative 2, we got that y was a positive 4. And when we plugged in x was positive 2, we also got that y was a positive 4. So it didn't matter if we plugged in the positive or the negative, we got the same answer at the end. Okay, so that's how we were able to compare with the even. All the other trig functions are odd, which means that when we plug in the negative angle or the negative x value, we're going to get the same digit, but we're going to get a different sign in front of it. So, sine of negative x is equal to negative sine of x. Cosecant of negative x will be negative cosecant of x. Tangent of negative x will be negative tangent of positive x. And cotangent of negative x is negative cotangent of x. And we compare that to like if we look at x cubed. Because if we have x cubed, when we plugged in x was a negative 2, remember y is a negative 8, but when we plug in x as positive 2, y gave us a positive 8. Because we got the same digit, we just got different signs because x cubed was an odd function. Same thing for the trig functions. Alright, so look at example 7. Here it says, if sine of theta is equal to 1/2, find sine of negative theta. Well, we know that sine of negative theta, which is what we're after, is the same thing as a negative sine of positive theta from the definition above. So in this case, we know it's going to be negative. What was sine of theta? Well, sine of theta was 1/2. And so we have a negative 1/2, which is just negative 1/2.